Okay, so we have these four resistors, and the first thing we're being asked to find, the first thing we're being asked to find is the equivalent resistance between points A and B. Now, I think this is the first time we've seen a problem like this where you got these points right here. This can be a source of confusion. It's like, whoa, man, what are those points, A and B? Look, those are simply just points. Very frequently, what problems will do is they'll give you points like this, and like notice in part B, it says calculate the current in each resistor if a potential difference of 34 volts is applied between points A and B. So what they're doing in the problem is they're going like this. They're going like, okay, between A and B, we're sticking in a battery. That's where you have a potential difference, right? So we're just going to go like that, 34 volts. So when you have these points on diagrams, you could stick a resistor in there. You could stick a battery in there. You could stick a voltmeter in there, an ammeter in there. In the lab tomorrow, I'm going to explain voltmeters and ammeters. Guess what voltmeters read? Volts. Guess what ammeters read? Amps, which is current. Okay, so we're just simplifying these resistors down. So you're going to start with these two guys. The 7 and the 10 are in parallel. The reason they're in parallel is when current hits this point right there, that dot, what's this current going to do? It's going to split, and that's the definition of parallel. Okay, so a 7 and a 10, you do the 1 over equation. You're going to go 1 over the equivalent resistance is 1 over 7 plus 1 over 10. You do the algebra, and the 7 and the 10 simplify to 4.12 ohms. Okay, so redraw the whole picture. You're going to redraw everything because that's how you do circuit problems. It's a lot of picture drawing. So here's point A, here's point like this. Here's the 4. So this is point A. Over here is point B. So we got 4 ohm. This guy is 4.12. And then there's our 9. So all we did going from this picture to this picture is we simplified the 7 and the 10. Okay? Now, we have 3 resistors here that are in series. So the way you simplify resistors in series is simply by adding them up. So this adds up to 17.12 ohms. And that's the answer to question A. That's the equivalent resistance of all 4 resistors. Okay, now B. Calculate the current in each resistor if we put a battery between points A and B, a 34-volt battery. Okay, so we'll put a battery in here. We'll just add this to all the diagrams. 34 volts. 34 volts. 34 volts. Okay? Now, how many currents are in this picture here? How many separate, unique currents do we have? 3. There are 3 currents here, so let's label them. Labeling currents is important. So let's call the current out of the battery I. So I comes in like this. Now, right there, what happens to I? It splits. So let's say that the current going up this way, let's call that I1. And then the current going down this way, let's call that I2. They're different currents because the resistances are different. Current follows the path of least resistance. So the 7 ohm is going to have more current than the 10 ohm. And then what current do we have over here? What are we going to have here? We're back to I. Right? It's the current out of the battery before branching. Okay, look at this middle diagram. Guys, what current is flowing through this circuit here? What current is in this diagram here? Is it I, I1, or I2? It's I. It's the current before branching. It's the current out of the battery. Okay, now one thing you should know. What do we know about current through resistors in series? It's the same. Even though the resistances are different. Okay? What current is flowing through this diagram down here, the most simplified? I. Right? That's just the current out of the battery. All right, so the way you're going to start this is you're going to go to the most simplified picture. Typically with circuit problems, you break the problem down and then you start working your way back up by solving it piece by piece. So for example, if you look at this most simplified diagram down here, if you look at this guy, this is a nice circuit because it's one resistor, one battery. So we can easily find I. I is going to be delta V over R. That's just Ohm's law. Now, what's the voltage across that resistor? 34. The reason I know that, so if that's 34 volt battery, that means the positive plate is 34, the negative plate is 0. So right here we got 34 volts. Right here we have 0 volts. So we got 34 volts across that resistor. And then the resistance is 17.12. So this gives us a current of just under 2. Okay, so we've now figured out that I is 1.99 amps. On the quiz, I just round that to 2. 1.99 amps. Okay? All right, now, how do we figure out the other two currents? I1 and I2. The only remaining thing to do in this problem is we need to figure out I1 and I2. Now, here's the way to do it, right? To figure out I1, so go right here. So I1 is going to be delta V over R, right? That's Ohm's law, just rearranged. We have the resistance. The resistance is 7. But now the biggest mistake kids make is they're like, V. Oh, there's a V right there. Would that be correct to plug in 34 volts? That's the voltage of the whole circuit, right? We need to figure out the voltage across the 7 ohm resistor, which, by the way, is the same as the voltage across the 10. The easiest way to do it is go to this guy right here. Who is this guy that I just boxed? Who is that guy? He's these guys, right? If you can find the voltage across that guy right there, delta V equals IR, can we find it? What's the current through that resistor? 1.99. What's the resistance? 4.12. The delta V across this guy comes out to be 8.18 volts, which means what's the delta V across the 7? 8.18. What's the delta V across the 10? 8.18, right? Let me just make this a little more clear. Dude, start at the battery. 34 volts, 0 volts. So how many volts right here? 34. How many volts are over here? 0, right? Now, how many volts do we lose across this first resistor right here? Let's just, 1.99, let's just make it 2. 2 times 4 is 8, right? So we lose 8 volts across this first guy, right? Which brings us down to what? Right there would be what? 26. How many volts do we lose across the next guy? Well, 2 times 4.12, that's going to be what? So this point right there. So we're losing 8.24. So what's that going to be? 26 minus 8.24. So about 17.76. And then how many volts do we lose across this next guy? About 18, the remaining. So it brings us back to 0. Anyway, you go to this diagram, do the exact same thing. 34 volts. Over here is 0 volts. So across the first guy, you lose 8. So that point right there has to be 26. This point right here, you could work backwards and figure out that this point has to be about 18 volts. So you could figure out the delta V across those resistors. Okay? All right, so back to my original calculation. Finding I1. The voltage across the 7 is 8.18 volts. So you divide that and you get 1.17 amps. That's the answer to I1. And then to find I2, you do the same thing, only change the 7 to 10. And you get 0.82. Final comment. What do you notice about 0.82 and 1.17? If you add those two currents together, what do you get? You get the total current. The current before splitting must equal the current after splitting.